For more problems and videos like this for linear algebra, you can take a look at Sarai Studies. Link is in the description box below. You start with your leftmost non-zero column, that's this one. Your pivot position is at the top. Your goal is to kill everything below it. So I want to kill this. I want to kill something that is in row 2. I want to use whatever is inside my pivot position to do so, and that is in row 1. Then my equation becomes plus whatever is here, which is row 2. And to find out what I need to do to manipulate this so that this becomes 0, I'm going to write these 2 rows down here. Then I ask myself, what's my goal? My goal is for this to be 0. That's the first entry. So here, the first entry should be 0. Then I focus on this column and I ask myself, what can I change so that this plus this gives me 0? Well, this would have to be a minus 1. How do I get that to be a minus 1? Multiply by a negative 1. But whatever I do to one entry, I have to do to the rest of those entries in that same row. So we're going to do minus row 1. So this becomes a minus, this becomes a minus, this becomes a minus. And then we can add just like we were. And I got what I wanted. 1 minus 1, that's 0. 2 minus 2, 0, 0, 0. And this is my new row 2. Since the only row I'm changing is row 2, these 2 rows stay the same, and row 2 becomes this new row 2. Now this is my pivot position. Everything below it's 0, we're good. You see a 0 row, you want to make sure that's always at the bottom. So we can do a row switch with row 2 and row 3. So we just switch these 2 rows. Now since I'm done with this column, I'm going to cross out the row and column corresponding to that pivot, and then I'm going to focus on the submatrix formed by doing that, which is this one. And you repeat the same steps again. So you start with the leftmost non-zero column. This is a 0 column, so you skip that. Then we focus on this one. This is not a 0 column because not all of them are zeros like here. And your pivot position is always at the top. Then your goal is to get everything below it to be 0, and it is. So you're also done with that one. So you cross out row and column, you focus on the remaining submatrix formed, you repeat the steps, you start with the leftmost non-zero column, but the only column is 0, so you're done. This is already in row echelon form, and you can check. Remember ZO plus 1C, this is for row echelon form, this is for reduced row echelon form. All 0 rows are at the bottom of the coefficient matrix. Check. Does it pass a staircase hack? Well, you take your pivot positions or your leading entries in row echelon form, you start and then you only go down when you see another leading entry, and then you keep going. If the height of each step is 1, then you're good. It passes the staircase hack. And then are all entries below the leading entry 0? Yes? Yes. So it is in row echelon form. I want to get it to reduce row echelon form. But first, let's actually check. So remember, it's ZO plus 1C. It's already in row echelon form. To get it to reduce row echelon form, the leading entries have to be 1s, and they are, check, and they should be the only one number in their columns. So if you look at the columns, are they the only numbers other than 0? Yes. You look at the column, is this one the only number other than 0? Yes. So it's also in reduced row echelon form, and we're done. And that's it for this video. I'll see you in the next.